Hillary wanted to put up wind. If you have a windmill anywhere near your house, congratulations. Your house just went down 75% in value. And they say the noise causes cancer. You told me that one, okay? You know, the thing makes it so, and of course it's like a graveyard for birds.
Today we will be discussing the feasibility of wind energy in addition to fact-checking some of the claims made by the infamous Donald Trump. Turbines harness the kinetic energy of moving air particles and convert them to electricity. As seen on the left, wind turbines comprise of four major components: the blades, the rotor, the nacelle, and the tower. Within the nacelle, a generator is used to convert mechanical energy from the spinning rotors into electricity. Brakes are used if wind speeds are too high for safe generation. Next, we will discuss the positive impacts of this technology. As seen from the DOE costing chart, the variable cost for wind is zero. This has resulted in wind pool price costs averaging 3.7 cents per kilowatt hour in Alberta, which is lower in comparison to the average price of electricity in BC of roughly 6 to 7 cents. Secondly, wind energy has zero emissions as it does not involve burning fossil fuels. This is the major benefit as it aligns with our plan in fighting climate change. Also, it does not require the use of fresh water. Furthermore, although onshore farms can be integrated to its surroundings, offshore farms will take this footprint to zero. This area could then be used for vegetation growth, which would then be considered a carbon sink to offset other emitters. Finally, in contrast to Donald Trump's false claim, there is no evidence linking turbines to cancer. Wind energy can also drive economic growth. The Canadian Wind Energy Association believes that wind energy can satisfy 20% of Canada's electricity demand by 2025. The benefits include $79 billion in new investment, 52,000 new high-quality jobs, and $165 million annual revenues for municipalities. This is all while reducing Canada's GHG emissions by 17 megatons annually. There are, however, some drawbacks to wind power. Initial capital costs of these farms are large. They can often be 30% more expensive than fossil fuel generators, which can deter investors. Next, they are usually built in remote locations far from cities where the electricity is needed. This requires long transmission lines, and maintenance work will be expensive in the ocean. There is also, of course, the marine impact. This is a major barrier for this technology if it were employed off the BC coast, with the already endangered southern resident killer whales. Sounds that are of low frequency can travel thousands of kilometers in water and will impact their ability to find food and communicate. Energy demand must be met by instantaneous power generation. In other words, the turbines will only supply energy if sufficient wind is blowing. This unpredictability does have negative impacts to the grid that will be discussed later. The EIA charts here show the variability by region. The major takeaway here is the need for electricity trading. A potential solution is that northern regions can carry most of the load during the winter, while southern regions will export their wind power during the summer. The spread of wind energy throughout Canada is heavily weighted on the east coast. Nova Scotia is of great interest for wind energy as the potential for offshore wind shows promise. Nova Scotia has large offshore wind speeds and a high concentration of potential locations. Wind speeds need to be at least 25 km per hour in order for wind turbines to be a feasible option. Offshore wind speeds tend to be faster and more consistent due to the Earth's boundary providing less friction than land. The energy available in the stream of wind increases cubically with wind speeds according to the actuary disk model shown in the formula. Furthermore, the majority of Nova Scotia's energy needs are currently being met through coal plants, which emit 6.5 megatons of CO2 per year. What would the introduction of an offshore wind farm look like in the province? The introduction of a hypothetical wind farm was done by using hourly wind speeds from the Beaver Island Lighthouse for an entire year and with the tabulated assumptions. The residual load duration curve was constructed using the Vancouver Island load scaled to meet the energy demand of Nova Scotia. Although this wind farm has decreased the total load on the grid, fossil fuel plants are still needed for variability concerns and base loads. With the introduction of this wind farm, the CO2 emissions are reduced by 171 kilotons per year. This is equivalent to a 10% overall yearly decrease. We hope this presentation has been informative and has allowed you to justify your own opinions. Thank you for your time.